How to run a multiple regression. So I look at my data set and I see in my data set I have first the y variable, which is the dependent variable that I will try to predict based on x1, x2, x3, x4 and x5. Before I start, I notice that the variable x5 is a series of yes and no, which cannot be analyzed in Excel. I will have to transform them. So let us first try to transform those observations using find and select. I will find all the no and replace them with a 1. 11 replacement. I will find all the yes and replace them with 0. Replace them all. Transformation is done. If I have another variable which does not contain numerical value, then I will also have to transform using find and replace. I am now ready to run a multiple regression. I will go to data, data analysis, and I will look for regression. Here it is. Once I run my regression, I have to identify which one is my y and give it the range. So here is will be my column of y values. My x has to be also identified here, going from x1 to x5. The label should be clicked because I noticed that on the first row, those are the name of the variables. The next option, I will decide where I want my output to be. I like to have the output on the same page. So here it is here. Would I like to see the residuals? Maybe the residuals plot, maybe the plot of the line. And then I click OK. The observation, the new window, gives me several plots. It gives me my residuals and different information. But the most important for me is to look at the outcome here. I look at this portion. This is the analysis of variance table. It tells me with a p-value of only 1.56 times 10 to the minus 7. That means I take the dot, the period of my 1.56 and go backward 7 times. So it is definitely below 0.5. I look at the printout here. That the first column here gives me the equation. Therefore, y is equal to minus 595 plus 2.497 x1 plus 1.867 x2, 3.126 x3 minus 128 x4 plus 2.45 x5. Once I have recognized the equation, I like to know if my coefficients are significant. In order to do that, I will look at the p-value corresponding to my x1, x2, x3, x4, x5. I see that x4 is the largest p-value. Therefore, I want to run my regression again without x4. Therefore, I will go back and I will remove x4 from the equation. And now I will run my regression again on a pool of variable that does not include x4. Now it's only over x1, x2, x3 and x5. The output variable should be assigned to a different place, not to right over the previous one, and I run it again. One more time, I look at the p-value. Are there values that are above 0.05? Yes, x5 has a p-value of 0.61. This is the largest of all. Therefore, I will run my regression again without x5. Therefore, I remove x5 from the regression. I run the data analysis again regression. I regress the same y, but this time I will regress only on x1, x2, and x3. Here we go. My output variable, again, I have to assign it to a space on the graph that will not cover any of my previous results. So I will put it here. And there I go. And I run it again. Now my regression has one more coefficient that is not significant. x3 is not significant. Then I run my regression without x3. I will do so until all the p-values are below 0.05. Let's go run it again without x3. Data, regression. I regress on the variable without x3. So therefore it's only on x1 and x2. And I will see now where are my values. And here we have a new regression where all my p-values are less than 0.05. This is my final model. The model of the ANOVA here is significant. It is my final model because the p-value corresponding to the coefficient of x1 and the coefficient of x2 are both below 0.05. I hope this can help building a multiple regression model.